now we need to figure out the concentration of this. You see, the first step is what? Is equilibrium. Then that means the forward reaction and the backward reaction have same rate, have same reaction rate. Because equilibrium. There's equilibrium there. Then here. Because it's equilibrium, then the forward and the backward reactions are the same in rate. And here, from here we know the chlorine equals here. It's really complicated, okay? It's really complicated. And then we can put this value to this equation. Then equals so for red law, we can only put what? The concentration of reactants, not intermediate. This chlorine is an intermediate. This chlorine is intermediate. And from here you can see what? You can see fraction, right? You can see fraction. You can see the reaction order of chlorine is half. It's not whole number anymore. It's not whole number anymore. So this question is quite difficult. Okay, then we'll move on. Question 79, right? 79. Identify which of the pair is catalyzed. So the catalyzed one should have smaller activation energy, right? So if you look at the first one, which you look at A, wow, it's kind of confusing. For A, there's A and B. Well, any question?
Oh,
yes.
I was wondering. So the answer that you
Here.
the final one, would that be the final answer, or were you
Yeah,
just
this will be
kind of
final answer.
explaining? Okay.
This is going to be the final answer.
Thank you.
No problem. For question 79, you see which one has this compared to A. In question A, for 79A, which one has smaller activation energy, A or B? They both have this kind of shape, right? So they both have this shape. The activation energy should be the energy difference so this is activation energy. As you can see, the activation energy for A is around how much? How many? Is around 24 minus 12, right? 24 minus 12. For question A, 24 minus 12 equals 12. It's around 24, right? 24 minus 12. And for B, how much? It's 20 minus 12. So B has smaller activation energy. Then B is catalyzed. Okay? B is catalyzed. And for question B, it's like that. Then again, the activation energy will be this one. And for A, the activation energy is 44 minus 2. Equals 42. For B is about 31 minus 2, right? So for B, this is, is also B, because the activation energy is smaller. Then for both cases, the B is the catalyzed one. Any questions? In this 81. Yeah, estimate the activation energy. So I will let you do the work. You see, this is what? This is the ectothermic reaction. It's like that. Again, the activation energy should be the difference between the transition state and the starting state. Transition state is about 35 kilojoules, right? The starting state is 10 kilojoules. It's about 25 kilojoules. 35 minus 10, 25 kilojoules. For question A. So again, here we can calculate. So yeah, for question 81, we can also calculate. So we need to differentiate the activation energy and what? Enthalpy change. Okay, enthalpy change. They're two different things. Any questions? Well, if no questions, then I think we're done today, and we can still have a few minutes. And